Welcome back to Kafka Internal's Crashcasts. I'm your host, Sheila, and today we're diving into the fascinating world of Kafka Streams. We're currently in Level 2, Jedi Knight, exploring the Kafka ecosystem chapter. Victor, are you ready to help our listeners become stream processing masters?
Absolutely, Sheila. I'm excited to unravel the mysteries of Kafka Streams for our audience. It's a powerful tool that every Kafka enthusiast should know about.
Before we dive in, let's start with a quiz question for our listeners. Here's a brain teaser. What's the key difference between batch processing and stream processing?
Oh, that's an excellent question, Sheila. It really gets to the heart of why stream processing is so important. I'm curious to see how our listeners will approach this. There are a few angles to consider, like data volume, processing time, and real-time capabilities. But let's not give away too much. We'll reveal the answer at the end of the episode.
Great point, Victor. Now, let's start with the basics. Can you give us a quick overview of what Kafka Streams is and why it was created?
Certainly. Kafka Streams is a client library for building applications and microservices that process and analyze data stored in Kafka. It was created to simplify stream processing and make it accessible to Java developers without the need for a separate processing cluster.
That's interesting. So, it's like a toolbox for developers to work with streaming data directly within their applications. How does this compare to other stream processing frameworks like Apache Flink or Spark Streaming?
Great question, Sheila. While Flink and Spark Streaming are full-fledged distributed stream processing engines, Kafka Streams is more lightweight and tightly integrated with Kafka. It doesn't require a separate cluster, making it easier to deploy and manage. However, it's specifically designed for Kafka, unlike the others which can work with various data sources.
I see. So, it's a trade-off between simplicity and flexibility. Now, can you explain some of the core concepts in Kafka Streams? I've heard terms like KStreams and KTables thrown around.
Absolutely. Think of KStreams and KTables like two different views of a river system. KStreams are like the flowing river itself, a continuous, unbounded sequence of records. KTables, on the other hand, are like a lake fed by the river. They represent the latest state or aggregate view of the data.
That's a helpful analogy, Victor. So, if I understand correctly, KStreams would be useful for processing each individual event, while KTables would be better for maintaining an up-to-date view of something like a user's current balance.
Exactly right, Sheila. You're catching on quickly. Now let's talk about some of the key features that make Kafka Streams powerful. One important aspect is its stateful processing capabilities. Can you guess why this might be important in stream processing?
I would imagine it's crucial for operations that need to remember previous events or maintain aggregations over time. Is that on the right track?
Spot on, Sheila. Stateful processing allows Kafka Streams to handle complex operations like windowed aggregations, joins between streams, and maintaining materialized views. This is essential for many real-world use cases.
Speaking of real-world use cases, can you give us some examples of how companies are using Kafka Streams in production?
Certainly. One common use case is real-time fraud detection in financial services. Banks can use Kafka Streams to process transaction streams and flag suspicious activities based on patterns or rules. Another example is in e-commerce, where companies use it for real-time inventory management and personalized product recommendations.
Those are fascinating applications. It really shows the power of processing data in real time. Now, I'm curious about best practices. What should developers keep in mind when working with Kafka Streams?
Great question. One key best practice is to design your stream's topology carefully. This means thinking about how your data will flow through your application and how different operations will be connected. It's also crucial to consider fault tolerance and scalability from the start.
That makes sense. Are there any common pitfalls that developers should watch out for?
Definitely. One common mistake is underestimating the importance of proper data serialization and deserialization. Another is not considering the impact of stateful operations on memory usage and recovery time. It's also easy to fall into the trap of overcomplicating your topology when a simpler design would suffice.
Those are valuable insights, Victor. As we wrap up, could you share a fun fact or interesting anecdote about Kafka Streams?
Sure. Here's a fun one. The name Kafka in Apache Kafka comes from the author Franz Kafka. In one of his stories, The Metamorphosis, the main character transforms overnight. You could say that Kafka Streams allows your data to undergo its own metamorphosis, transforming raw events into valuable insights in real time.
That's a clever connection, Victor. Before we go, let's reveal the answer to our quiz question. The key difference between batch processing and stream processing is that batch processing operates on finite, static datasets, while stream processing works on continuous, unbounded data in real time.
Excellent summary, Sheila. Stream processing allows for real-time data analysis and decision-making, which is crucial in today's fast-paced digital world.
Thank you, Victor, for this illuminating discussion on Kafka Streams. To recap, we've covered its purpose, core concepts like KStreams and KTables, real-world applications, and best practices. In our next episode, we'll be diving into the schema registry, another crucial component of the Kafka ecosystem. Don't forget to subscribe and rate our podcast if you've enjoyed this episode. Until next time, keep streaming.